Hello, good evening everyone. Today we are going to talk a topic on digital design and computer organization. And the lab 8 question is design overlock program for implementing various types of flip-flops such as SR and JK and D. Clock is a note. Clock is a CLK is a clock. RST is the reset input and Q is the output signal. When RST value is 1 and Q will remain as 0, during the simulation, right click on a RST variable in a wave window. Select force constant and type the value 1 and click on OK. Right click on the CLK variable in wave mode window. Select force clock, enter the leading edges as 0, trailing edges as 1 and period as 1 US and click on OK. Now run the simulation. Next, right click on the RST variable in a wave mode, select the force constant and type the value as 0 on clock OK. Now run the simulation and verify the output signal. Here it is. Now we shall discuss about the D flip-flop. D flip-flop is used in electronics to store the binary information. Here these are the fundamental building blocks in digital and play as a crucial role. Here D flip-flop module DFF of D, Q, QB, CLK, RST. Here D is the data input and CLK is the clock input and RST is the reset input, where Q is the output representing the state of the flip-flop. Here QB represented the complicated output. Here register QB. These are the registers that stores the current state of the flip-flop and its complement. Okay, and always at pose at CLK begin. Here this statement gives the information that block is triggered on the positive edge of the pose edge of the clock signal, giving the name it as a CLK. If RST of Q is less than or equal to 0, this asserts the flip-flop is to be reset and Q is to be set to be 0. Else, if RST is not asserted, it enters the block and checks the value of the data that the input is D. If D is equals to 0, if D equals 0, then Q is set to be 0. If D equals 1, then Q is is set to be the set 1, and in case and using the end module, not end module, and end. Here the assign statement in QB is equals to not Q represents that this line states that assigns the complement of the Q to the QB. It calculates the complement of the current state which has been used in the D flip-flop, and here the program end and is the end module. And now we shall start studying of SR flip-flop. Here the SR flip-flop consists of a module SRFF of SR, Q, QB and CLK resist. Here input SR and CLK RST represent. S represents the set input and R represents the reset input, whereas CLK represents the clock input and RST represents reset input, where Q is the output representing the state of the flip-flop and QB is the complemented output. Here register declarations of register Q of QB represents, these are the registers that store the current state of the flip-flop and its complements. Here always at a post edge CLK begin. Here this block is always triggered on the positive edge of the clock signal CLK. If RST signal is asserted, flip-flop is reset and Q is set to be 0. If RST is not asserted, then it enters the value of the block and checks the values of the set input S and reset the output out R. Here set the inputs as S and reset the output as R. If SR is equal to 2 is to B00, indicating that the change in Q remains unchanged, and the change 2 is to B of 0, 1 SR, indicating that the set of operation is set to be Q. And here if SR is SR of 2 is to B1 is 0, indicating that the reset operation is set to be 1. Same as usual, if SR value is 2 of B11, indicating the invalid state of both set and reset is left in the undefined using the mux X. And now we are end case and end, and now we assign QB is equals to not Q. This line assign QB, this line represents that assigns the complement of the not to the Q, and it calculates the complement of the current state, and end here the end module. Now we shall start discussing about the JK flip-flops. JK flip-flops, module of J, short formly we can name it as JFF, of inputs J, K and K, QB and CLK and RSAT. Here inputs are the J, K and CLK RSAT, where J is the input, J of set of operation, and K, using the value of K, is the input of the K reset operation, and CLK is the clock input, and RSAT is the reset input, where Q is given as the output representing the state of the flip-flop, and QB representing the complemented output. Here register Q as QB. These are the registers that store the current state of the flip-flop and its complement. And always at block CLK, this block indicates that the block is triggered on a positive edge of the pulse edge of the signal, clock signal CLK. If the signal RSAT is Q is less, assert to the flip-flop reset and Q is set to be 0. Else, if RSAT is not assert with the end, it enters the else block and checks the values of the J and the K inputs. Here it is K inputs, checks the inputs of J and K. If JK of B00 smash Q is less than equals Q, indicating that there is no change in Q, remains unchanged. If J of K is 2 is to B01, indicating that the reset operation is Q is set to be 0. And same as usual, if J of K of 2 of B equals, indicating the value input values of 1 0, that is indicating the set of operation Q is less than, is changing to 1. And now if a JK of 211 Q, indicating that toggle operation Q is complemented to the not Q, and here the end case end, and assign QB of is equals to not Q, indicating that this line assigns the complement of Q to the QB. It calculates the complement of the current state. Here the module end in the end module. That's all.